Hello students. Last time we have studied about one factor at a time approach for medium optimization, and the second part we have studied is full factorial design. We have studied what are the advantages and disadvantages of one factor at a time and full factorial design. So the last part that we end up with of full factorial design was regarding the two types of factors, numerical factors and non-numerical factors, in which we have learned that if the number of factors are more, then obviously the number of numerical factors are going to be increased. So if the number of factors increases, the full factorial design, it becomes more and more complicated. That means that leads to increase in the number of experiments which may not be possible to perform at laboratory level also. Therefore, to find out a solution for that, the solution for that is to take help from statistical approach. So in this lecture, we'll learn about the statistical approach, how exactly it is used for the optimization of medium, sequential nature of statistically designed experiments. So this is a protocol to be followed in order to optimize the medium. The first step. Now, ideally, the experimental design is a sequential process. First, categorical factors are studied to determine which nutrients and physical conditions are of importance for optimizing the fermentation. Then a large number of continuous factors. So in the first step, categorical factors means non-numerical factors. In the second step, continuous factors means numerical factors. So these continuous factors may be in between a number of 5 to 12 in general are screened, and insignificant ones are eliminated in order to obtain a smaller, more manageable set of factors. So we have learned in full factorial design, the limiting factor is the number of factors, number of categorical factors, and number of continuous factors. So if this number is reduced, then studying each and every factor in detail is possible. So therefore, the next step would be to eliminate the insignificant factors. Insignificant means the factor which does not have a significant effect on the response. Response means output of an experiment. The remaining factors are then optimized, means insignificant ones are eliminated and the significant ones. So the significant factors are then optimized by response surface methodology or modeling. And finally, after model building and optimization, the predicted optimum is verified, and for this verification, again, one factor at a time approach will be utilized. So this doesn't mean that one factor at a time approach is never useful. It is useful when the number of factors are very less. So this is the sequence in which how exactly the medium optimization is done. Briefly, the factors are selected, then these factors are screened in a statistical design. Insignificant factors are eliminated, and only significant factors, which are very few in number, are then optimized using surface response surface methodology, and again we go back to one factor at a time in order to get a optimized medium. So what are these statistical designs? These are called as screening designs. So the objective of the screening designs is to identify most important factor, means most significant factors among a large number of factors. So for this, these screening designs are used. One of the screening designs is described by Plackett and Burman. These designs are called as Plackett and Burman designs. The objective of this Plackett and Burman's design is to identify the most important variable or the most important factor in the system. Most important factor means the factor which has significant effect on the response. For example, in case of vitamin production, vitamin concentration will be the response. In case of antibiotic fermentation, concentration of antibiotic will be the response. So the factor which affects the production of vitamin, which affects the production of antibiotic, or in all which affects the fermentation response, that factor will be called as significant factor. So Plackett and Burman design, it consists of two level screening design. Two level means, here level means concentrations of factors. So how many concentrations of factors we can test here? Only two: high level and low level, high concentration and low concentration. So it is in general when more than 5 independent variables, means factors, are to be investigated, then we need to take help of Plackett and Burman's design, because more than 5 independent variables means the number of variables are very high, and therefore full factorial design may not be possible. Experimentation will be more and more laborious. Therefore, we take help from Plackett and Burman's design. So when the number is more than 5, Plackett and Burman design may be used to find out the most important variable in the system, which is then optimized in further studies. This is the objective of Plackett and Burman's design, to find out the most important variable in the system, most significant variable in the system. Significant means which has a significant effect on the response. Means if you change the concentration of that factor from low level to high level, it shows an effect on the response. Now, these designs are meant for the study of up to n minus 1 factors with n number of trials. So, number of trials are more as in comparison to number of factors. Now, this is the property or characteristic of this design. Earlier sentence, that is study of n minus 1 factors with n trials. That means if there are 7 factors, then you need to perform 8 trials in order to evaluate the 7 factors. But this n must be a multiple of 4. That means it should be 8, 12, 16, 20, 24, and so on. So there are hundreds of designs of Plackett and Burman. So if the number of factors is 5, then what design you should choose? We can choose a design of 8, because according to the earlier formula n minus 1 with n trials, the number of n comes 6. If the factors are 5, the value of n will be 6 trials. But 6 trials are not mentioned in Plackett and Burman design. So we should go for next trial, that is a set of 8 trials, a set of 12 trials, and so on. These are the typical designs which are frequently used by the researchers: 8 trial design, 12 trial design, 16 trial design, 20 and 24 trial designs for the evaluation of more than 5 factors. So the designs are selected closely in multiples of 4 based on the number of factors that are needed to be evaluated. There is a common practice to select a design of 12 trial to test 6 to 8 factors. This is in general. There may be variation, but most of the times the problem is to evaluate 6 to 8 factors, and the solution chosen for that is to select a design, a 12 trials, Plackett and Burman design. Now we'll try to understand this with an example. Let us consider a newly discovered antibiotic from a producer organism, and we need to design a production medium for the maximum production of this antibiotic, which will be measured in micrograms or milligrams per ml. And for example, if there are 7 factors which are required to be investigated. For example, if we choose a design of 12 trials, Plackett and Burman design, for the evaluation of these 7 factors. So the choice of factors and factor settings. So as I mentioned, Plackett and Burman design is a 2-level screening design. Levels means settings, levels of factors, settings of factors, 2 concentrations of factors. So choice of factors and factor settings is based on prior experience while growing the antibiotic producing organism and literature. That means the question arises, why 7 factors? So we assume or we collect the information from previous research, books, and literature. And understanding that information, collectively we can conclude or we come up with 7 factors. So based on the previous experience and the literature, we can select the important factors. So in this example, if there are 7 factors, the choice of the factor settings, that means what should be the concentration of these factors. Now this is a very critical issue in the design of any fermentation medium. So we can get the solution of that from the literature or from the previous published work. So the choice of factor settings or labels should be much wider so as to produce a change in the response, That means the concentration of factor should be such that it should have some significant effect on response. Means the concentration of factor should be low enough to have an effect on antibiotic production. The concentration of factor should be high enough to have an effect on antibiotic synthesis or production. Factors for Plackett and Burman design for a new antibiotic fermentation. Now, these are the factor settings. This is just an example. So, in the first column, factors are mentioned. In the second column, factor settings are mentioned. Sub columns mentions low concentration and high concentration. So these low concentrations can be abbreviated as L, high concentration as H, or some books describe it as -1 and +1 respectively. Suppose these are the factors which are identified as important for antibiotic fermentation. This is the basic composition, or we can say that it is the basal composition of the medium that we gathered the information from literature. So the medium should consist of cane molasses and several others. So what should be the concentration of cane molasses here? So it is selected as 10 milligrams per ml at low concentration and 40 milligrams per ml that will be considered as high concentration. How do we get these values? We predicted these values from the literature, from books, from research papers. So look at the difference. 30. The difference is very big and which is to considered to have a significant effect on antibiotic production. Likewise, other levels are also selected for other factor. Cottonseed flour, it is low, 25, high 100 milligrams per ml. Corn strip liquor, it is 5 and 20 milligrams per ml. Yeast extract 5 and 20. Soybean meal 15 and 60. Fish meal 15 and 60. And FeSO4 5 and 20. This is the general basal composition of fermentation medium which is selected for this new antibiotic fermentation, and the task is to identify which of the following factors are significant, and in order to resolve this task we are using Plackett and Burman's design. After factor settings, the next step is to select a 12 trial design. In this example, 12 trial Plackett and Burman design is selected for the study of 7 factors in new antibiotic fermentation. What are the 7 factors? These are the 7 factors. So for time being, you can see that these factors are abbreviated as 1, 2, 3, 4, 5, 6, 7. Let us try and understand this table. This is the Plackett and Burman design table, a 12 trial design. First column shows the trials from 1 to 12. Trial means the experiments, the number of experiments to be conducted. And the second column shows factor settings for different factors from 1 to 7. From 1 to 7, these are the factors abbreviated as 1 to 7. Now you see that this is a 2-level screening design. So you will find that there are only two levels which are mentioned in this table. Low level is abbreviated as -1 for factor 1, and +1 is abbreviated as a high level for factor 1, which is true for second factor, third factor, fourth factor, fifth, sixth, and seventh factors. The other characteristics of this design are, if you consider factor number 1, so factor number 1 is tested in 12 trials, in 12 experiments at low level and at high level. So you can see that out of 12 trials, 6 trials means 50% trials are conducted at low level and 50% trials are conducted at high level. This is true for all the factors. Say for example, factor number 2, you'll find that there will be 6 trials out of 12 in which factor 2 is tested at low level, and factor 2, 6 trials in which factor 2 will be tested at high level. This is true for all the factors. So all the factors out of 12, they will be tested. You will find that its level is -1 in 6 trials and its level is +1 in the rest of the 6 trials. So this shows the balance, complete balance in the design. All the factors are tested at two levels. Now, let us consider factor number 1 and factor number 2 in columns in relation to the number of trials. This will help us to understand that all the possible combinations of all the factors are tested in this 12 trials. So if we consider factor number 1 and factor number 2, just check out the trials in which factor number 1 is tested at low level. So these trials are trial number 1, 2, 3, 4, 5 and 6. So these are the trials, 6 trials in which concentration of first factor is low. If you compare these 6 trials with factor number 2, you will find that out of these 6 trials at which factor number 1 is at low level, 50% of the trials will be conducted at low level of 2 and 50% of the trials will be conducted at high level of 2, like this. So trial number 1, 2 and 3, these are the 3 trials in which factor number 2 is tested at low level, and rest of the levels, trial number 4, 5 and 6, in these trials you will find that factor 2 is tested at high level. So out of 6 trials of factor 1, if you compare that with factor 2, 50% of the trials will have low level of factor 2 and 50% of the trials will have high level of factor 2. This is true for all the columns or all the factors. You can compare factor 1 with factor 3. You can compare factor 3 with factor 7, and you will find the same condition. Just for the sake of convenience, let us compare last two factors, factor number 6 and factor number 7. So as I mentioned earlier, you need to mark the trials at which factor number 6 is tested at low level. So these are trial number 1, trial number 4, trial number 6, 7, 9 and 11. So these are the 6 trials where the concentration of factor 6 is low. So out of these 6 trials where concentration of 6 is low, 50% of the trials you will find that factor 7, where the factor 7 will be at low level, and in 3 trials you will find that factor 7 will be at high level. So out of these 6 trials where concentration of factor 6 is low, in 3 trials you will find that the concentration of factor 7 is high. It is trial number 1, trial number 4 and trial number 11. And 50% of the trials in which factor 6 is at low level, you will find that factor concentration of factor 7 will be at low level 2. It will be trial number 6, trial number 7 and trial number 9. This is how the justification is given. This is the typical characteristic of Plackett-Burman design. This helps us to understand that all the possible combinations of all the factors with different factor settings are put together in only 12 trials. So in Plackett-Burman design, low and high factor settings are coded as -1, +1. For example, the coding of a 12 trial design is mentioned in earlier table. Notice that each factor is tested an equal number of times at its low and high settings. So 6 trials are at low level and 6 trials are at high level for each factor that we have seen. So there is an equal allocation of factors and balance exists between each pair of factors. For example, of the 6 trials tested at low settings for factor 1, 3 are tested at each of low and high settings for factor 2, as I mentioned or explained you in the earlier table. So this balance, it exists between every pair of factors in the design. This equal allocation and balance makes statistically designed experiments complete and very efficient. So as compared to one factor at a time and full factorial design, this method is at all not time consuming. Now, let us fill up that table. This is the table that was selected from the Plackett-Burman designs, a 12 trial design for the evaluation of 7 factors. Now let us put some real values in this. So these are the trials and these are the factors with settings. So I have replaced 1 to 7 with actual names. Factor number 1 is cane molasses, then cottonseed flour, constip liquor, yeast extract, soybean meal, fish meal and FeSO4. Now let us replace the values of -1 and +1 which were mentioned in table number 1. What are these factor settings? For cane molasses, it is 10 and 40. For cottonseed flour, it is 25 and 100, and so on. For FeSO4, it is 5 and 20. So wherever -1 and +1 were mentioned, now we have replaced it with actual concentration in milligrams per ml. So you can see that trial number 1, or the first experiment, will be conducted by using the production medium having composition of 10 milligrams per ml of cane molasses, 25 milligrams per ml of cottonseed flour, 5 milligrams of corn-strip liquor, yeast extract 20 milligrams per ml, soybean meal 15 milligrams per ml, fish meal 15 milligrams per ml, FeSO4 20 milligrams per ml. So this will be the composition of the medium for first trial. This is how you have to prepare 12 such media with different concentrations. So you will have 12 combinations of media. So the first medium will be inoculated with the producer organism, incubated at defined temperature. After incubation period is over, the broth is harvested and its antibiotic concentration is measured. Second experiment, third experiment, all the 12 experiments are run in a parallel fashion. All these different media are inoculated with production medium, incubated, and after incubation, all the broths are harvested and the concentration of antibiotic in all these different experiments which were run independently is determined. This is how the process happens. So at the end of all the experiments are run, what you get is a response. Here the response is measured in the form of antibiotic concentration, that is in milligrams per liter. So this is the response. So the response for first trial is 1.21. The response for second trial is 2.95. The concentration of antibiotic produced using a combination of ingredients in 12th trial is 6.55. This is the output of the experiment, that is in the form of antibiotic. In the last column at the bottom, extreme right bottom, 3.8 to 1 is mentioned. This is the average value of all these responses. So that is for the purpose of next calculation. So what do you conclude from this? We cannot conclude anything from this, or otherwise you will say that which is the trial showing highest response will be the optimum, will be the optimized medium. No, the optimization process is not yet over. You can see that it is I think it is the 12th trial which is showing the highest response, 6.55. This doesn't mean that the medium composition should be this for the maximum production of antibiotic. No. The objective of Plackett and Burman design is not to find out the composition of the medium. The objective of Plackett and Burman design is to find out which is the most significant variable. Means whether cane molasses is significant, cottonseed flour, or corn-strip liquor and yeast extract and soybean meal and fish meal, FeSO4, out of these 7 medium ingredients, which is the medium ingredient which shows a significant effect on antibiotic synthesis or production. Means if you change the value of cane molasses from low to high, changing these concentrations, whether it affects the production of antibiotic or not, that is evaluated in this Plackett-Burman design. So after the statistical analysis is performed, will identify or will come to know out of these seven which factors are highly significant, means which factors have a significant effect on antibiotic production.